Hello guys, welcome again on benchmark video series, and on this video I'm going to show you benchmark between Node.js and Vert.x. So it's gonna be an event loop battle since both of them are adopting event loop architecture at their core. Alright, as usual on this benchmark I'll be using three servers. One is for sending the requests using Gatling performance tool, and the rest will be used as application server and also database server. Since on this benchmark we not only testing the web server but also how it can handle with update operation. And also from Gatling server I'm going to inject about 1000 to 2000 HTTP requests per second for total duration of 50 seconds. Okay, let's jump into the benchmark. First, we're gonna see the Node.js performance. Okay, now I have two terminals here. The left terminal is SSH from Gatling server, while on the right one is showing the htop resource monitoring from app server. Okay, since the Node.js application is already running, we can start the test. But first I want to verify whether the request to be sent is correctly configured. Okay, so far it's correct and we are about to send between 1000 to 2000 requests per second. Okay, now let's start the test. Okay, test is started and requests are also being sent. Now on the right side we can see that the CPU bar is spiked to 100% right away. Let's hope it can handle all the requests. And on the left side we can see Gatling is showing the success and KO request every 5 seconds. Currently the KO request is still 0. Okay, so far so good with Node.js, even though CPU is operating on 100%, but I doubt it's gonna last until the end of the test. Now we can see the first report of KO requests on 35 seconds, and with every 5 seconds the KO requests are increased. And yeah, let's wait until the end of the test. We rather see the report generated by Gatling. And now the performance test for Node.js is finished, and based on the report that is generated by Gatling, from about 75,000 requests that was being sent, more than 42k requests are KO. It's more than 50% compared to the OK requests. And when it comes to time distribution below, we only find slight response that can be considered as fast. Fast response is the response that took less than 800 milliseconds, while the majority of it are considered as slow and failed response that took more than 1200 milliseconds or more than 1 second to finish. Okay, now let's go to see Vertex. Okay, as usual, on Vertex, I need to verify the request configuration. And if this is correctly configured, then I can start the performance test on Vertex. Okay, it's correct, and let's start the test. Okay, now we can see same on Node.js, the CPU bar is spiked to 100%, indicating that most likely the available resource of CPU cannot handle all the incoming requests. And if this is the case, I'm afraid soon it's gonna throw the KO request. Okay, we've got our first KO request on 40 seconds, but as we can see so far, it is not as much as on Node.js. But let's wait until it's finished. Okay, the result is generated, and we can see clearly from the test result that Vertex can perform way much better than Node.js, with OK request is dominating the result with about 95% of the requests of 71k OK requests from total of 75k. And also below we can find the on the time distribution some percentage of fast and medium response. Okay, that is the result from Vertex, and it's clear to see that Vertex is the winner of this event loop battle. And I believe it's caused by JVM that operates the JIT compilation on specific time, meaning that on small or majority time portion, Vertex was running as native application. But I also believe that Node.js can also perform much better than Vertex, or at least same as Vertex when we compile it to native application using GraalVM, if you have heard about it. Okay guys, I hope I can make it to compile Node.js to native app, and will gladly show you the rematch between two of them. And so far, that's it from me. I hope you guys learned something and also entertained by this benchmark. See you next time.